Boom, and they're live. What's going on, guys? It's your boy Andy, you're on Algopedia, and we are going to solve the problems from the last Codeforces round. First of all, you know the deal. If you're here and you haven't joined the party, make sure you like this live stream right now. Make sure you subscribe to the channel for more wisdom and after contests, value and tutorials. And yeah, show me some love in the comments, pressing those buttons, subscribing to the channel and sharing these tutorials with your friends. Let's see. I don't know if you can hear me. I hope everything's fine. So yeah, please start with problem F. Wow, that was pretty amazing. So you were 27 and then 1 second later I saw 13 or something, just half. Maybe it's a bug, who knows. Alright, so tell me in the comments, what do you want to see? Basically, I have managed to solve each and every problem of the round, which is pretty cool, but it was a div-free round, so yeah, nothing, let's say, very impossible at the first sight, but it was quite cool. It wasn't that easy, so yeah. Alright, binary search for D, please start with problem F. And great, logic for F. Alright, so I already see two of you guys which one start with problem F, and I think I should do that and then we will see. So first four problems weren't that tricky, right? I mean, I think everybody kind of got it. Even problem E from problem F, it was kind of a greater gap. So yeah, let's start with F. So spy string. Okay, basically, you know the problem. We are given n strings and all of them are of the same length, which is m. The strings consist of lowercase English letters and we should find one string, they call it S, such that this string differs from each and every of these n strings from the input by at most one character, right? So for each string there is no more than one position j such that that string ai and s are different in position number j. And that's it. We should find one of these strings. Cool. Well, I read the problem and first thing that I notice is, of course, n is at most 10 and m is at most 10, right? So at this point the problem seemed pretty interesting, but when I saw 10 and 10, that's like, I can do something like n at power 5, or let's say 5 because I have 100 tests and I can get away with it. So I should really go nuts and think about big complexities, right? And that's what I did. It was as simple as that. So what happens here is that you want this final string to differ from each and every of those n strings by only one character. So first of all, it has to differ with the first of these n strings by only one character, right? So I thought about the first string. I've took the first string, a of 1. Let's take some example because it's easier. For this example I have, we don't even need to draw or something, a, b, a, c, right? So that string s is either equal to the first string, a, b, a, c, or it differs by only one character. So what did I do? Is that I have tried each and every possible string. And that is all, right? So that string s is either equal to a1, as I said, or I take each and every character, right, each and every position from 1 to m, and I choose the character which will replace the character in the first string, and I have that word, and then I move on and try that word. And how do I try that word? I just brute force all the way, right? Fix position, fix the character, and then go through each and every string and just compare it brute force and check if they differ by only one letter. And that is all. Yeah, so we don't need to draw. We can actually look at some piece of code. I guess that's pretty good. So yeah, let me see if I can do something about the zoom. I don't know. Yeah, I can. All right, cool, perfect. You should be able to see pretty well. So as you can see here, right, I had a function is valid, which is here. This function is valid just checked if my answer is valid or not, right? And what do? Well, because I know the answer is going to be okay with the first string, because I convert the first string into the answer, I check for each and every other string between 2 and n. And I have a counter, and I basically count how many different characters I have. And that's all. I take each and every position between 1 and m and just increase the counter if they are different in that position or not. And of course, if the counter is greater than 1, I return false. Otherwise, in the end, after I know it's cool with all the other strings, I return true. And for generating this answer, I just initialize it with the first word. So answer of I is answer of 1 and I. And then I check if it's valid, because this is the first option. And if this is not valid, I try each and every position from 1 to m, right? And as long as I haven't found a solution, basically I try each and every character, which is different by the character in the first word, and if it is, I replace it and I check again if it's valid, right? The final time complexity is something like m positions, crossed 25 different characters which could replace the initial one, crossed the isValid function which performs another n crossed m. So is, I think, something like 26 crossed n cube, which is super okay. It's like 26,000, and because I have 100 tests, I have something like 2 million operations, which is super cool. Yeah, and that's it. That was problem F. It's basically some brute force approach. Nothing special, guys, nothing special. All right. Who wants to find out how to solve problem G? There is some delay. So yeah. Okay. Anyways, let's go and solve problem G. This is also a cool problem. Again, in this live stream, the problems were quite creative, intuitive. We don't need to draw something, or we can just look at the code and talk. So yeah, basically what we had to do here is that we have 4 integers, n, m, a, and b. And all of them are at most 50. So again, they are really small, right? And what we should basically do is create a matrix which has n rows and m columns, a binary matrix, right? And so just values of 0 and 1s, such that we need to satisfy 2 properties. The first one is that each row of this matrix contains exactly a1s. The second one, each column of the matrix contains exactly b1s, right? So that's all. I have to say yes if there is such matrix, or no if there isn't, and of course if there is, to output the matrix, right? Alright, so I see here constructive algorithms, flows, graph matchings, math. No, there's no need for that, man. I mean, I think the proof needs graph and matching and something like that, but we won't get in the proof of the algorithm, but let's just stay logically and solve it intuitively, right? So what happens? Well, when I have this kind of problems in which I have to print yes or no, I first see the empty half of the glass and I think about, when should I print no? So when is it impossible to construct such a matrix? Well, each row has exactly a1s. Each column has exactly b1s. So, if each row has exactly a1s, the number of 1s is exactly n crossed a. If each column has exactly b1s, then the number of 1s should also be equal to m crossed b. So this is the first thing I'm going to check. First of all, I'm going to check if n crossed a equals b crossed m. If it doesn't, I print no. If it does, I print yes. I suppose I can do this. And let me tell you why I suppose that. Because at this point, I have thought about the problem in the following way. So let's see. D, how many did you solve? D, character. Yeah, no, I'm not solving Code Chef lunchtime, unfortunately, but if it's worth solving, maybe I'm gonna try that too. So yeah, basically what happens here is that, how I thought about this, right? So I thought about, all right, basically what I need to do is for each row, choose exactly A columns and increment the total sum on that column, right? So what can happen here is that, let's do a custom one. All right, I got some here. All right, cool. So let's do an 80%, right? Cool. You could think about this in the following way. You can think that for each row, I basically choose A different columns and I increase their sum, right? So what I can say here is that I can start with something like column sums, an array, column sums, right? Which has each and every column, 1, 2, 3, all the way to column m, right? So m minus 1, let's say, and m here. And initially, the sum on each column is 0, right? Because I don't have anything on that column. So the sum on each column is 0. And for each row, let's say here, step number 1, step number 2, and so on and so forth until step number n, right? So for each of the rows, I basically choose A different columns and I increase their sum by 1. So what should I do? First, I thought that I will always choose exactly A columns, right? So A columns, which have the sum less, strictly less than B, and I just place 1 there. The problem with doing this is that you are going to fill some columns very quick, right? And I think I have an example for that. Do I? I don't know if I have, but anyways, the problems were something like, so first of all, I thought, all right, for each of these n steps, I'm gonna go through the columns and I'm gonna pick A columns which have the sum strictly less than B, and that's all, increment those. The problem with this greedy approach is that you are going to increment some columns very, very quick, and they are going to become B, and basically you are filling them. You are filling them, right? Their sum gets to be really quick, and when it does, basically that column is unavailable anymore, right? So what happened in the previous approach is that, let's say if A was equal to 4, basically at each step I've taken the same 4 columns B times, right? So on the first B steps, I just increased those columns by 1, those columns by 1, those columns by 1, right? So I only do that because they are the first columns that I find with the sum less than B. So after B steps, these columns become unavailable. And after a couple of steps, a lot of columns will become unavailable, and I won't be able to choose exactly A columns which have sum strictly less than B, right? So I have to be a little bit more cautious and calculated with how I pick those columns, because if I pick the same columns over and over again, the number of available columns in which I can store a 1, right, is going to decrease very quick, right? So I need to do something such that On each step I choose a columns, but I don't end up choosing the same columns over and over again. And then the whole idea came to me. I don't know how to prove it super mathematically, but you probably don't want that. It's super simple. Instead of choosing A random columns with the sum strictly less than B, you choose the A smallest column sums. And that's all. So you basically have m total columns, right? You have a total of m columns. You start with only zeros. And at each and every step, you have here some sums. You take those columns which have the sum strictly less than b, and instead of picking a random columns, you just pick the a smallest column sums. And that's all, right? So basically, for each and every step, again, because the number of rows and columns is very small, I could just brute force. So for each and every step, I go through the columns, right? And I store this column sums in some array, right? Call sums, I can tell call sums, okay? And basically I keep this array sorted. You can do this smarter with a priority queue or a set, or you can just sort this array over and over again for each of the steps, right? So for each and every step, I take this array, I sort it, sort call sums, and I just pick the first A columns anyways, and I have ones there, and that's it. So recap, first of all, check if A crossed N equals M crossed B. If not, print no. If yes, then print yes. And for having a solution, don't pick random those columns, but be smarter about it and always pick from the columns which still are available, so have the sum strictly less than b, pick the smallest a ones, right? And you are basically going to have something something good. So yeah, cool. If you want to see the source code, it's not that hard. So basically, as I've told you, n crossed a, m crossed b, if they are different, no, else cout yes. And what I did is that for each and every row between 1 and n, I took the vector of pair calls, which is the column sums, and for each column which has a sum, right, counter was the number of ones there, less than b, I push it into this vector and I sort this vector. So as you can see, I have a n crossed m log, which is not very efficient, but they are small, so I didn't care. And after sorting, I just take the first a and I take that column, I increase the counter, I place a 1 there, and basically that's it, right? So yeah, if you want to prove that it is always correct to pick the smallest a integers and increment them, because it seems right, it's intuitive, but in order to prove it mathematically that it's 100% correct, I think you're going to need some theorems from graph theory. I think I've learned them in university or something, but of course I forgot them, so yeah, you're gonna have to do your research. But that was it. So, who's ready for problem H? Let me see. Who is online? Hi Saurav, what's up? What's up, my man? So yeah, cool. Let's see, problem H, are you ready? Should we do problem H? Let's do this, I think we're ready, right? So problem H, I don't know how many of you have read it, if you tried to solve it during the contest, but it was kind of cool. So let's see, from problem H, basically you are given the length of some strings, which is m, right? So you basically start off with each and every binary string of length m, right? There are 2 at power m, such strings in total. And okay, then you are told how they are lexicographically smaller than others. You know what lexicographically smaller means, so I think that's cool. And from this set, which contains initially 2 at power m strings, you will remove n distinct binary strings, and you are given those strings, right? So you start off with each and every binary string of length m, you remove n of them, and then you are asked to print the string which is the median from the remaining set, right? So take all the strings, remove those n strings that are given in the input, and then sort lexicographically the strings and give me the median, basically. That's what the problem asks, right? So yeah, all right. It wasn't that hard, let's say, and it was pretty interesting. So how did I think about it? First of all, I thought about a way simpler problem. I'm thinking like, all right, so what's gonna be a simpler problem? Let's suppose I don't remove any string, basically, right? So I have all those 2 at power m strings of length m, and I keep all of them. If I do that, and I need the median, so the string, which is basically 2 at power m minus 1th, lexicographically the smallest, right? So basically I need that. All right, cool. So let's think about it. If I don't remove any string, it's pretty simple, right? Because when you deal with binary numbers, binary strings, basically the kth lexicographically smallest string is number k written in binary form, and that's it, right? So yeah, the smallest is 0, then the second smallest is 1, right? Then you have 1 0 1 1 and so on and so forth. It's really simple. The whole difficulty of the problem is given by the fact that we remove some strings. So I'm thinking about this. Let's say this median, this position, which is 2 at power m minus n plus 1 divided by 2 or something. I think that's the formula of that index. Let's note it with some k, right? So I have to find the kth smallest lexicographically string. Cool. I thought about that. K is going to be pretty big, right? Because m is 60. So I can have something like 2 at power 60, right? K is less or equal than 2 at power 60. So if that happens, what I have to do is find a way of finding this kth smallest number without performing k operations or something like that. So it's kind of a classic problem, right? I mean, it's that type of problem in which you have to build from scratch the kth smallest yada 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 number. It's a constructive algorithm, right? On all of the problems which ask for the kth smallest, especially lexicographical string, it is a constructive algorithm, because you are going to think first about the first character. And you are going to say something like, if the first ever character is 0, then the number is good, could be the smallest one. If it's 1, then I know there are 2 at power m minus 1 smaller number than that, or something like that, right? So I knew this is going to be a constructive algorithm. And at this point, I'm just thinking about the constructive algorithm. And let me show you how simple it was. So what I have to do here is that I'm going to construct a number which has length exactly. Let's take an example. Yeah, let's take an example. I think that's cool. Alright. What should we do here? Let's take the second one, 4, 3. Alright, so I have to build a number which has length exactly 3, so m equals 3. So here I have 3, 1, 2, 3. And the numbers that I have erased are 0, 0, 0, 1, 1, 1. Let's write them down here. 0, 0, 0, 1, 1, 1. 1 0 0 0 1 1 1 0 0 0 1 1. Cool. So I have removed these numbers, right? Cool. And n is 4, m is 3. So from all the 2^3 numbers, I subtract 4 of them. And by the formula, I have to increase 1 and divide it by 2. And I get an 8 minus 4, 4 plus 1, 5, divided by 2, which is going to be 2, right? So I need the second smallest binary number of length m, right? Of course, which is not in this set, right? So what's it gonna be? I think it's gonna be 0, 1, 0, right? Am I right or not? Yeah, it's 0, 1, 0, right? Because what can we do is we can have 0, 0, 1, and that's valid. We can have 0, 1, 0. We can have 1. We can have 0, 1, 1. We can't. We can have 1, 0, 1, and so on and so forth, right? And they are lexicographically increasing, right, in this order. So basically what I think about at this point is super simple. Is I just ask myself what's going to be the first character, like in any other constructive algorithm, right? So I take a look at the first character and I'm like, it could be 0 or 1, right? All right, what if this character is going to be a 0? So basically, I'm gonna have a number of length 3, which starts with a 0. How many numbers of length 3 which start with a 0 are there? Exactly 4. Then, what are going to be these numbers? Let's say 0, 0, 0, 0, 0, 1, 0, 1, 0, and 0, 1, 1, right? Now, from all of these numbers, which are 4 of them, I have to say how many of them are not in this set, because these are the numbers that we have removed initially, right? So 0, 0, 0 is not anymore. 0, 1, 1, basically, yeah. So what I have to do at each point is, for the first position initially, if I had a 0, from these 2^m minus 1 numbers, like in this example 2^2, which are 4, I have to subtract how many numbers are in this set which start with a 0, and I find 2 of them, right? So at each point I have to do that, right? So for example, here I have 4 numbers minus 2 of them start with a 0, so I'm going to have exactly 2 numbers which are going to be subtracted, right? So I have a total of 2 possible numbers, which are these 2, right? So what I found out here is that if I start my number with a 0, this number is going to take only 2 possible values. And I have to see what is my k. Oh, k equals 2. So I have to find the second smallest number, and if I start with a 0, I have the second smallest number here. Cool, so this is a 0. And I move on. Then, position number 1. What if I have a 0 here? Well, how many numbers are there which start of length 3 which start with 0, 0? There are 2 of them, right? 0, 0, 0 and 0, 0, 1. How many of this 0, 0, 0, 0, 0, 1 are in my set? Well, 0, 0, 0, and that's it. This is the only one which starts with 2 zeros. So only one of them. So from 2^m minus 2, right? From 2^m minus 2, I'll have to remove 1 because it was removed initially, and I get a total of 1 number. Alright, so if I had a 0 here, I have only 1 number, so only the smallest possible number, but I need the second smallest. So it's quite clear that I won't have a 0. I'm gonna have a 1 here, and because I'm gonna have a 1, from this k, I'm going to subtract this value, which is 1. So k minus equals 1, and it stays 1. And then, because k is 1, I try again here a 0, and I have to find out, alright, I have only one possible number, and 0, 1, 0 is not in this set, so this means that this is a valid one, right? So it's like any other classic constructive algorithm. You just go increasingly with the positions and first try the smallest lexicographically option, and if that's a valid one, you stick with that. If it's not, you remove how many integers would have been in that option, and you are left with k minus that number, and you have 1 there, right? So just a recap, we are going to see the code then. What I do is basically this thing. So for each position, which is from 1 to m, right? So I pick the digits increasingly by the position, so in the order of importance, from the most important to the least important. I think that's the word, yeah. For each position, I first try, what about the answer on that position is 0? Could it be a 0? How will I find it? Well, I have to do something like this. From the total of 2 at power m minus that position number, right? If we fixed the digit on position, pos, we have a total of 2 at power m minus pos integers. Subtracted by how many of them, from the set that is given in the input, has exactly the same prefix of length pos as my answer. So if the answer by now was 0, 0, 1, 0, and then we don't know, right? And we are here on pos, I need to know how many of the numbers in that set have this prefix of length 4 equal to mine. And I'm gonna extract them because they are removed. Let's note this number by x. I compute this number. So I just try the 0, call this function. We are going to see how to implement this function. And let's call it x. And I have the following options. If x is greater or equal than k, this means that if I pick the 0, the number I'm looking for is going to be in my range, which is cool. So if happens x greater or equal than k, then it's all good. Answer on position pos is for sure 0, and we continue. If x is strictly less than k, that means that the number I'm looking for is not in this range. So I have to look further for greater numbers, which means that ans on pos is not 0 but 1. And because it is 1, I have just passed through all those numbers which would have been obtained by setting this digit to a 0. So k is going to be subtracted by all those values because we won't get to any of them anymore. So k minus equals x. And that's it. Again, this is a classic constructive algorithm. You know the deal. Basically, that's the whole template for this kind of things, right? So yeah, this is not a 1 or a 2. This is the only thing that we have to check, right? So we just check if this can be a 0 or not. And the how many function, because again, the limits are not very tight or something like that. Like m is 60, n is 100. You don't have to have an optimal solution here, right? If you want it to be faster or optimal, you could use something like a trie, right? Which is that data structure that looks like a tree and has letter links, right? You could use something of that, or you could use some fancy bit masks or something like that, right? But here, because the limits are pretty small, you could do something like a brute force. So let's see what I did to compute those numbers. Let's see, in the source code, right? So what I did, again, as I've told you, basically, let's start from here. For each and every position from 1 to m, I see what's going to happen if I store a 0. So I have how many 0 equals how many of I and 0. And this means how many numbers are going to be equal to me, right? No, how many numbers are going to have the same prefix of length I with me if I would have to store a 0 here, right? So let's take a look at how many of pos and c, and the counter is initially 2 at power m minus pos, as I've told you. And then we are going to subtract those numbers which were in that set and have a prefix of length pos equal to mine. So what I do is that I basically try out each and every number from 1 to n, and if that number is valid, and is valid means that on the previous step it had the same prefix as me, right? So if I want now to have the same prefix as me, this means that on the previous step it had the same prefix as me, and now this character is a 0 just like me, or in my case in this function c, right? So what I did is that if is valid, so the first pos minus 1 characters are the same, and character pos is the same, then counter minus minus, because it's in that set, it was removed, so I have to remove it from this ones too. And I just return the counter. So I basically know that x, how many numbers are in my range, right? So this is the x, and I just query. If x is greater or equal than k, then I can stick with the 0, I set it as 0, and I update valid. What I do here is that, of course, after I set this as 0, I'm gonna need the new is valid array to be updated for the next step, right? So I take all those valid strings which were true, and some of them are going to be now false because they were true. The first pos minus 1 characters were okay, but now the pos character maybe is not, so they are not valid anymore, right? So what I do basically is that I know that I'm gonna have a 0 in my solution, and I update those strings. They are not going to be valid anymore. And else, if this is less than k, then the number I'm looking for is not in this range. So I just subtract x from k. I set the answer to be 1, and again I update valid. And in the end I just print the answer. And that's it, guys. Constructive algorithm. Start small, start from the most important position, and just decide on the spot if it's going to be a 0 or 1 using this is valid and helper function. And basically that's it. Yeah, please solve D after this one, Andy. Yeah, man, I would do that, but I've already solved this, so yeah. Hey Kata, what's up, man? I miss you. You're my bro. Some fellow Romanian competitive programmer guys there, power on that one. Romania has a pretty nice competitive programming community, so yeah, we are pretty cool. I have a lot of friends which are cool. So yeah, this was the round, guys. It wasn't quite that hard, but please, special attention on this kind of problems. F, G, H. Oh, you wanted D. Oh, Saurav wanted D. Alright, yeah, we haven't solved D. We started with F, I think. Yeah. Alright, so we started with F, G, and H. If you want D, I can talk about D for a little bit. It's not that hard. So right, on problem D, let's just say it quick. What happens on problem D is that what you have to do is basically by the statement, it's not hard to notice that you are going to find the greatest divisor of n, which is less than or equal to k. This is what the problem asks for. What is the greatest divisor of n which is less than or greater, which is less than or equal to k, right? So yeah, all right, and you have 10 at power 9 and 10 at power 9, so they are quite large. But the thing is that we all know that mathematical trick in which when you want to compute to find the divisors, or at least to check if some number has divisors or not, you can iterate until s squared t of that number, right? So it's that math trick optimization, which instead of trying out each and every divisor or possible divisor between 1 and n, you try them between 1 and s squared t of n. And why do you do that? You do that because, let's take a number, n, right? If you find all its divisors, you can group these divisors into pairs, right? Let's say for n equals 100. I can group it like this, 1 and 100. Their product is n. 2 and 50, their product is n. 4 and 25, their product is n. 5 and 20, their product is n. 10 and 10, their product is n, and so on and so forth, right? So basically for each number, you can pair its divisors such that the product of those two divisors equals exactly n. And if you do this, in each of these pairs, you are going to have one number which is less than or equal to s squared t of n. Because if you have two divisors greater than sqrt, their product is not going to be n, right? So greater than sqrt cross greater than sqrt equals something greater than n, right? So it's pretty obvious that if you group them like this, one of them, the smallest one, is for sure less than or equal to sqrt of n, right? So you can use this kind of property, and what will you do? Is look for divisors. Oh, that's not it. Oh, I think that's it. Oh yeah, that's it. That was a piece of code from other problem, I think. All right, yeah, that's it. So yeah, what you're gonna do is that after reading n and k, you are trying out each and every possible divisors between 1 and sqrt of n. If n is not divisible by d, then you continue. That's not a valid one. And if it is, then you have the pair d and n divided by d. You have this pair of divisors, right? And you see, if d is less than or equal to k, then you try to update the answer if d. So answer is the maximum between answer and d, and the other divisor from this pair, which is n divided by d, if it is less than or equal to k, then you update answer by n divided by d. And that's all. You have found in answer the greatest divisor, and the answer is n divided by that divisor. And that's it, right? Pretty simple. Come on, it's not that hard. So yeah, basically that's what you have to do with this problem. So use that mathematical trick with the pairs to go only and iterate for sqrt times not the whole number. So yeah, that's it. This was div 3. I hope you got it, guys. C. C was not that hard. Come on. I mean, yeah, I can explain you C, but it wasn't that hard. Polygon, this was a cute one too. Unfortunately, we don't have time to go through all of them, but yeah. I think I can explain C. It wasn't that hard. So C, what you had to do is that you had an array of even length, and you had to split this array into pairs, right? So let's say if you had 20 elements, you can have these 20 elements split into exactly 10 pairs of 2 elements, right? And you could have only similar numbers in each pair. Two numbers are similar, either they are of the same parity or they're different by just 1, right? So 2 and 6 are similar because they are both even. 11 and 7 are similar because they are both odd. 4 and 3 are similar, but not because they have the same parity, but their difference, their absolute difference is exactly 1. So we have to construct pairs from this array. So that's basically simple. What I thought about was something like this. I have n numbers, which is even. Let's split these numbers into even ones and odd ones. So now I have two sets of numbers, even numbers and odd numbers, right? Because n is even, the number of even numbers plus the number of odd numbers is even. So I have two possible scenarios. Either the number of even numbers and the number of odd numbers are both even. So let's say 4 even numbers and 4 odd numbers. 6 even numbers and 6 odd numbers. Or these two numbers are both odd. Let's say 9 even numbers with 9 odd numbers, because together they are 18, which is even. So on the first scenario, in which I have a number of even numbers which is even, this means I can group these numbers into pairs. If I had 10 even numbers, I can get 5 pairs of 2 even numbers, basically, right? If the number of odd numbers is also even, because this is even, if the number of even numbers is even, then also the number of odd numbers is even. So let's say this is 14. Okay, I get 7 pairs, which consists of only odd numbers, which is cool. So in this first scenario, in which both these numbers are even, it's quite simple. You always print yes, because it's possible, right? The problem is when you have an odd number of even numbers and an odd number of odd numbers. For example, 7 and 11, right? Together, they still give me an even n, but they are odd. What happens here is that because this is odd and this is odd, I can't have pairs with numbers only by the same parity, right? Let's take, for example, 7 with 11, right? With 11 odd numbers, how many pairs I can get? 5, and I still have one remaining number. With 7 even numbers, I get 3 pairs, but I still have one remaining number, right? So this is the problem here. If this is odd and this is odd, I'm gonna have to take an odd number and an even number and get them together, and then this is even and this is even, and I can do the previous trick. So in the case that the number of even and odd numbers are both odd, I just have to check if there is some pair in this array such that one number is even and one number is odd and they are similar. Well, the only option for this is that they are consecutive. So what I have to do here is basically sort the array and check each and every pair of consecutive numbers after sorting and see if they are consecutive. If in this array I find a pair of consecutive integers, I pair them together, and this is a valid pair, and then I'm left with even number of even numbers, even number of odd numbers, and I can group them by the same parity, right? So that was it. The whole trick, the whole difficult part was finding a pair of consecutive elements, which you can do by sorting the array and then trying out each and every 2 consecutive elements. If you find one, you print yes. If you don't, you print no. And that's it, right? So yeah, that's it, guys. All right. G please. G was, I'm sorry, but I had explained G. Yeah, stay tuned when the video is going to render on YouTube. Yeah, so this was me, guys. Unfortunately, we don't have any time. If you want to see my solution on E or other problems, I'm gonna put in the bio my my source links. That's cool. So you are going to have in the bio my source code to each and every problem. And this was it. I hope you enjoyed the contest. I hope you enjoyed the live. This was Andy. Don't forget to like this live. Don't forget to subscribe to the channel and support the channel how much as you can, because you know I'm competing in Codeforces. I love Codeforces. You all love Codeforces, and I want to see as many as you learn as much as you can, and always solve the problems and try to get in the line of thought and build that foundation that if you have the foundation, you are going to solve each and every contest on Codeforces, and you are going to be like very fast, and it's gonna be like a piece of candy for you, right? So again, subscribe to the channel, like this live, and I can't wait to see you on the next live and on the next contest, right? Andy out. Everybody have a nice day, and thanks a lot. Stay tuned for when this live renders, so you can see again over and over again the solutions, and you are going to have my source code in the bio. That's me. Have a nice day, man.